So hello guys, I'm here to present to you the completely fair scheduler. So this completely fair scheduler is a process scheduler that was merged into October 2007 release of Linux kernel and is the default scheduler of the tasks of the schednormal class. It handles CPU resource allocation for executing processes and aims to maximize overall CPU utilization while also maximizing interactive performance. Then the history of Linux scheduler is early Linux scheduler used minimal design, obviously not focused on massive architectures with many processors or even hyper-threading. The 1.2 Linux scheduler used a circular queue for runnable task management that operated with a round-robin scheduling policy. This scheduler was efficient for adding and removing processes. Then the overview of completely fair scheduler is first is the main idea behind the CFS is to maintain balance in providing the processor time to task. This means processes should be given a fair amount of the processor. Then next is to determine the balance. The completely fair scheduler maintains the amount of time provided to a given task in what's called the virtual runtime. The smaller task, virtual runtime meaning the smaller amount of time a task has been permitted access to the processor, the higher its need for the processor. The next is the have a red block tree, which means is a tree with a couple of interesting and useful properties. First, it's self-balancing, which means that no path in the tree will ever be more than twice as long as any other. And second is operation on the tree occur in O time. This means that you can insert or delete a task quickly and efficiently. Then next is the completely fair scheduler internals. All tasks within Linux are represented by a task structure called task struct. This structure fully describes the task and includes the task's current state, its stack, process flags, priority, and much more. Then next is priorities and completely fair scheduler. CFS doesn't use priorities directly but instead uses them as a decay factor for the time task is permitted to execute. Lower priority tasks have higher factors and decay, where higher priority tasks have lower factors of delay. This means that the time a task is permitted to execute dissipates more quickly for a lower priority task than for a higher priority task. And that's all everyone. I hope you have learned for my video presentation and thank you for watching. Thank you.